Okay, by the end of the lesson, we're going to understand the properties of inscribed angles when they intercept or intersect the same arc or semicircle. We're going to understand the angle relationships in a cyclic quadrilateral, and we're going to learn what that word means, and understand the relationship between two arcs that are intersected by parallel lines. I didn't like that last one with the diagram that we're given. So I'm going to give you a different diagram, and you'll see why I don't like it and why it's confusing. If you give me my diagram, it's not confusing at all. Well, I don't think it is. Okay, what we're going to do with this is an inscribed angle. Do you remember inscribed angles? Where's the vertex? The vertex is on the circle. So here's your inscribed angle, angle CAR. Okay, and we know the measure of this arc because this is what kind of an angle? It's at the center. It's called a central angle. So what's the measurement of arc CR? That's it. It's not hard. Now, look at angle A. Do you think it's equal to 65, smaller than 65, or bigger than 65? Bigger. Look at the picture. There's this. There's that. It looks like it's smaller to me. Okay, well, let's find the relationship. I could just give you the relationship. However, if you forget it, you're in trouble. So let's remember we have a circle here. So what's true about the radii in a circle, Curran? What's true about the radii? They are what? Absent.
True about the radii that go to the center.
The radii are congruent. Isn't this length equal to this length equal to that length? So if I were to take this triangle out of here, I'm literally going to move it out and try and grab it. What kind of triangle is it? It's isosceles. So this is how you were to do some of the problems. You could still do the problems like this, but we're going to come up with a conjecture about the measure of the inscribed angle. Well, let's call that angle X, because I don't know what its measure is. And how big is this angle right here? 115. There are two ways to do this. One is to review, Cole, an old concept. Both are old concepts. If I take X plus 115, it's equal to 180. And then if I take the 115 and subtract it from both sides, I get what? I got to solve for X. I have to subtract 115 from both sides. I get 65. Interesting. Do you recognize, kind of remember, that this exterior angle is equal to the sum of the two remote interiors? Well, it makes it a little easier, but I can still do it the way I just did it. X plus X, the two other angles that are not next to the 65, are equal to 65, and there it is. And so how do you find X? You divide by what? No, I divide by 2.
Which is 32.
Okay, 32.5. What's the relationship between 32.5 and 65? It's half. The measure of an inscribed angle is 1/2 of the measure of the central angle or the arc that it intercepts. So here's my inscribed angle in yellow. It's half of either this central angle or this arc, because those are the same things. So you can use that now, or you can work with the triangles like I did. So if you forget, it's just going to take you a little bit longer. Okay, so you might want to write that down. That's one relationship we're going to do. Are we ready to go on? Let's try a problem. So if you know the theorems, it's a lot easier. How big is this arc? 105. How big is this angle? It's half of it. 1/2 of 105. I'm okay with half of 105, or if you prefer 52.5, that works too. That's all there is. If the vertex is on the edge of the circle, then the measure of this angle is half of the angle. If you look at the pictures, you can see x is smaller than 105. So if this is x, how big is this arc? This is 2x. It's twice as big as the angle, going the other direction. Does that make sense? So 2x equals 105. I don't care how you look at it. But if this is 10 degrees, and this is 20. Now that's not that hard, is it? The problem is when we get them all mixed up with some other circle properties. So I'm going to work on a study guide for you guys for circle properties. In particular, this is a special chord. What's special? It goes through the center. It's the diameter. Maybe, maybe not. Don't know yet. Well, we'll get to that theorem. So how big is this arc? If that's 30, this isn't 30, it's 60. If you forget, draw in this line from the center to that edge there, and you know that this is 30. And if you can remember this theorem is the sum of these two. Well, they're both identical, so it's twice that. So it's 2 times 30, or 60. That didn't answer any of my questions, did it? Well, let's find out what y is. Because this is a semicircle, how many degrees in that arc? 180. So we subtract 180 minus 60, and we get y, which is 120. The other one is similar. We're going to find out if they're parallel. Remember, we can't really assume. If this is 85 from here to here, how big is the whole thing? No, it's a semicircle. So it's 180 minus 85, which gives you 95, right? Did I do that right? And then think slowly. Don't jump to us too fast. It's either double or it's half. Look at, it's close. But look at x. Is it twice that or is it half of it? It's half of it. So it's what? 95 halves. What is it? 42.5. I'm okay with 95 halves. No big deal. Well, in the real world, we deal with a lot of fractions. If you ever cook, you're going to have to deal with fractions. Okay. Any problems with inscribed angles? Not too bad, right? These are inscribed angles. The angle, the vertex of the angle is on the circle. The central angle is exactly equal to the arc. This is the central angle. And you can see the central angle is bigger than that other angle. Okay, we're ready? What if I inscribe an angle in a semicircle? This is kind of interesting. Here's my angle that's inscribed. And this is, yes? Might be. Yeah, that wouldn't be right. 47.5. That's okay, but that's why I prefer to see 95 halves. Then I don't have to deal with that. Okay, I took that green angle inscribed in a semicircle, so this is always true. How many degrees here of the powder blue? That's 180. Then this green angle is half of that. What's half of 180? 90. What kind of angle is this? It's a right angle. Some of you may say, well, it's just the way you drew it. Let's draw another one. Let's put B over here. This angle right here is half of this intercepted arc. So it's still 90. So if you inscribe an angle in a semicircle, this is going to have to be the diameter. then the angle is always a right angle. So angles inscribed in semicircles are right angles. And I'll put a star by that. Should have put a star by the last one too. Inscribed angles are always half the intercepted arc. So I'll try to write up a study guide and have you fill in the blanks for all the relationships. Because if you can do that, then you know the material. Then, of course, no, you have to know it. Now, these are going to be ACT kind of questions too. Inscribed means to actually be writing with the vertex on the circle. Are we ready? Hey, TJ, do you know this? No, you don't. What's the, you ready? Cole, question? I put the vertex on the circle itself. That's what inscribed means. Scribe means to write. On the circle, not in the interior. We will get to ones with interiors. And there are theorems, or we could just figure it out. Sometimes it's just easier to figure it out. Okay, so there's a problem. Is this a semicircle? Yeah, that's its diameter. So how big is this arc? What's 180? Okay. So how big is, I want x, so I want this angle right here. It's half of this intercepted arc. I need to know what that is. That's 180 minus 60, or 120. So how big is x? 60. See why this assignment's going to take you a little bit of time? So that's 60. The concept isn't hard. The hard part is to recognize which circle property you're going to use. Is that okay? I just play with it like a puzzle. I could figure out this angle, which is a right angle, but they didn't ask me that. Would have been nice, because it would have been easier. Okay? So this is half of that arc. I know the whole thing's 180, so to get this piece right here, I have to subtract 60 from 180. Now, a cyclic quadrilateral, these points are on the circle. That's why it's called cyclic. So the vertices are on the circle. Now, proving this is a little bit tricky. But what do you think is true about the opposite angles? They're not congruent. They're supplementary. And I can prove it. If you want me to, I can. I'd rather wait, do it tomorrow. But they're supplementary. And I have to use the arcs and such. And it's not too tricky, but it's okay. I'd rather do it tomorrow. Okay, so opposite angles in a quadrilateral that's inscribed in a circle. In other words, the vertices are on the edges of the circle, will add up to 180. Whoops, didn't do that right. So now we're ready to try a problem. And again, put a little star there. That's another circle property. And at first, it may be a little daunting, but just work your way around the problem. Okay? I don't know a lot, but I do know I have a 95-degree angle here. So then I know how big this arc is. Oh, it doesn't look like it's going to help me any. How about using the fact that these add up to 180? Well, if I know those add up to 180, if I can figure out this angle, can I figure out this arc? Yep. And then I'll find out what x is besides. So x plus 95. There's a lot of ways to start this. Equals 180. What's x equal to? 85. So that's 85. And I could work all the way around this. I want to get y. Okay, so shall we find out what these pieces are? What's y going to be? Y is just this piece right here. Can I find this angle? A lot of ways to find that angle. X plus 83 plus 95 plus z equals how many degrees? 360. And I know what x is. X is 85. So 85 plus 83 plus 95. Let me fix that. Plus 95 plus my unknown angle equals 360. Anybody get a calculator out and tell me what big Z is? I don't know. I don't remember. You guys have calculators. Get your calculator out and figure it out. Once I have that, this angle intercepts this arc.
97.
It's 97? Okay, so this is 97. Then how big is that big? Let me change colors. How big is this green arc? Well, that's twice that.
Twice 97.
So 2 times 97, 194, right?
Then you divide by 2.
No, this is 194. No, this length around here is 194. This is 100. How big is what's left? 194 minus 100.
Because you used those.
Because it told me.
Angle Z.
Yeah, but if you want to go back and see why, there it is.
Oh,
Yes.
I understand it.
Shh. Vivian. These are opposite angles. They're supplementary. Which, of course, I just made this whole thing harder. This plus this are supplementary, too. I didn't prove to you why they're supplementary. I will tomorrow if you're interested. Either way. And I think I solved it entirely differently in the other class. So there's many ways to solve these problems. It doesn't matter. You could have found this arc. You could find this piece too. That's another thing you could do. You can find all those pieces. You have enough information. Okay? See why the problems are going to take you a little bit of time? Okay, we still have a lot left to do. Okay, the next one, are you ready? I don't like this picture because it says parallel lines intercept congruent arcs on a circle. Okay, TJ? It looks like minor arc AB is congruent to minor arc DC. That's not, I'm going to redraw the pictures, what I'm going to do. That is not, those are not the arcs that are congruent. They look like they are, but let me put in a line here and another parallel line here. Oops.
So do you only want to?
We're going to do the front page, but we're going to get through all the notes today. This arc here is not congruent to that arc there. What arcs are congruent?
They're parallel.
They're parallel lines, but these, the arcs cut off in between the parallel lines are what are congruent. I looked at the picture. The way the picture's drawn, it looks like these outside arcs are the ones that are congruent. It's not. It's arc AD is congruent to arc BC. Arc AD. Cole, is that okay?
Yeah, it is.
And only until I drew this picture here was it easier for me to see that. So let's label this A, B, C, D. So this arc is congruent to that arc and not those other ones. So that could be misunderstood very easily from that diagram. I misunderstood it. So if you have parallel lines, the arcs that are cut off in between the parallel lines are the arcs that are congruent. Okay, 2 more things to look at. How do you solve, oh, this is a rectangle, sorry. Oh, this is even easier. How big is Y? Because these are parallel. Yeah, that's 45. Now, to find that arc that's X, now you know this is a right angle. So if I draw from D to B, it's a special chord. It's an angle. How many degrees in this arc? How many degrees in that arc, Cole? 180. How many degrees in this arc? 180. So x is 180 minus 45, or 135. Well, I'm not trusting you guys. Now, why do I know that? Because when you take trigonometry, you're going to be doing lots of stuff with 45-degree angles. And I run into that 135 all the time. So that's why I know that. And you will too when you get to pre-calc. Okay, 2 more pictures. Ready? Oh, I'm sorry.
Shouldn't it be 21.5 both?
Because the arc is right here. That's the semicircle.
Oh.
Does that help to see the color? Which is why I have colored markers over there for you guys to borrow. If you're not on your iPad. Because you have your colors on your iPad. Okay, we ready? What if I have an angle that's inside the circle, but it's not a central angle? Kyle? Over here. Well, I actually thought the second slide was easier on this. So let's do that. Let's do it the same way I did the other class. Let's look at this one. Hey, Cole, my vertex is now outside the circle. There is a relationship, but you know what? I don't necessarily remember what it is. So what I'm going to do is we're going to draw a segment and get an inscribed angle with a triangle. So I'm going to draw this segment. No, I'm not. Let me try that again. I'm going to draw this segment right here. So I have this triangle. Pulling that out. Okay. It's not isosceles. I know how big this angle is. This outside angle is how big. Now, that's an inscribed angle, so that angle is half of that. What's 112 divided by 2? You know what? Do what I do, and I'm pretty good at this. No. Okay? This is 56. Now, here's another inscribed angle. How big is this angle? Paul? How big is this angle? It's half of that arc. So how big is that? 18. Okay, so we have x here. This is 18. We can find this angle. We know that this is 56. Or I can use the exterior angle theorem that says 56 is equal to the sum of the two remote interiors, x plus 18. You could find that and add it up to 180, but it's the same thing. You get the same result. I don't care what it is. And so what's x? 38? Okay, do you see how I drew what we call auxiliary lines? I drew a line in here so I could get inscribed angles. At least I think this one was easier to see than the other one. Now, if you want to know what the theorem is, to do this quickly and easily, if the angle, but I'm worried about this, if the angle is outside the circle, x is 1/2 of the difference of these two arcs. We're not going to actually formally do that. You could always just draw the lines, or you could remember the theorem. So maybe somebody has an idea what the one's going to be if it's inside. Well, if it's outside, it's a subtraction problem. If you're in Minnesota in the winter, it's negative, right? But if you're inside, it's nice and warm, so it's positive. Okay? Guess what this is going to be? It's going to be 1/2 of the 36 plus the 1, wrong one. This inside one is going to be half of the 76 plus 52. But let's do it. Yeah. This is the exterior angle theorem. call that Z. 38 plus Z plus 18 equals 180. See how I want to do this? And Z plus 56 equals 180. Those are equal. What happens to the Z's? I don't know if that helped me out. Well, that wasn't going to prove it to you. But I don't like that. I just remember that theorem. You don't have to. You can work it out the other way. Okay, you guys, we're going to draw a line in here, Cole. And we are going to draw this line. Okay? How big is this angle? No, it's not at the center. What kind of angles are these at X? Vertical. Okay. Now, can you just focus on this inscribed angle? If this is 76, how big is that? No, it's half of 76. 38, isn't it? I think it's 38. Now, let's go over here and let's focus on this one. How big is that one if this is 52? It's half of 52. 52 weeks in the year is 26. And if I can remember that exterior angle theorem, life is easy because X is equal to 38 plus 26, which is 64. It's half of 52 plus 76. What's half of 52? It's 26. What's half of 76? 38. So if it's inside, you take the arcs and you add them and you divide them in half. Does it work for a central angle? Absolutely it does. I'll let you draw your own pictures and do that. So all I did was I drew an extra line here. Hopefully they're not going to make you do that because I think that's hard to think of that. And that's it. So we have inscribed angles. Is 1/2 of the intercepted arc. And then we had angles inscribed in a semicircle. What's true about those? If you have half a circle and you inscribe an angle in that, what kind of angle is it? Sydney, what kind of angle is this? It's half of 180 degrees. That's 90. Okay, what else did we have? Then we had the cyclic quadrilateral. So if you have a quadrilateral inscribed in a circle, opposite angles are supplementary. Kind of nice to have this summarized in one place. Okay, Sydney? If you have parallel lines, in a circle, you get congruent arcs. Be careful which ones are congruent, because not both pairs are congruent. That picture is deceiving. And then the last two are some special cases. Okay, that's the big stuff right there. Okay, homework that's due for today or homework that is due for tomorrow? Okay, so let's look at that, and we're going to do questions too. I told you this was a little bit longer lesson. It is. Okay, so there's our homework. Answers are online. I've checked my answers, fixed my solutions, so my solutions should be correct. At least I thought I fixed them. Okay, we're going to slide down, and we can come back. Okay, number 4, that one. I would draw this, because what's true about a radius and a tangent line? They're perpendicular. So if I pull that triangle out, because I don't have enough room to work on it, this is 40, this is 90. How big is the central angle? These have to add to 90. 50. So that's 50. So how big is H, which is the arc?
Oh, the arc, that's it.
That's 50. I believe that's what that is. You should try to get through at least 8 so you can ask me some questions. Then that leaves us all of these tomorrow.
Oh, yes. So we only have to do April, May.
You should try to get, that should be our goal. You can go further than that.
Go back to the other one.
That one. Find out what this arc is. You know how big that arc is. So this is 40.
40.
You know how big this arc is.
This arc.
You have to find the whole thing. It all adds up to 360.
Yeah.
You have a semicircle. Yeah, you're gonna. If you have that list that I just did of all the theorems in this section,
Where's the list?
it's on my other slide, which I haven't saved, of course, but yet. Now, how about homework? We did all of these in the other class. We did 5 in here, I believe, right? 6 is goofy. I don't care about 6. How about number 7? Do you guys know how to write the equation of a line? Okay. You guys, you know y equals mx plus b. I don't like y equals mx plus b. Too many fractions. Okay, TJ? It's y minus y1. I think this is a hard problem because we have to remember some things. Mx minus x1. That's point slope form. Be honest. Have you seen that before? We need to know that, and if it isn't, I'm going to make sure before we leave this class. Well, where does this come from? It comes from slope formula. Remember slope formula? It's the change in y divided by the change in x. That's slope formula. If I cross multiply, I get y minus y1 equals m times x minus x1. You may not like it, but it's the easiest form that we have. And these are the constants. These are numbers. All I have to do is go into the problem and pull up the numbers. The only thing that's hard is the slope. So it's y minus, what's my y coordinate here? Look at the picture. What's the y coordinate? TJ? 15. Equals my slope. I'm going to leave that for a moment. And it's x minus the x coordinate. I always do what's easy first. Cole, what's x coordinate? 8. Now for the hard part. You need to find the slope. But here's the deal. I want the slope of this line. First question is, can you find the slope of that line? Do you remember how to find slope? It's rise over run. Okay, so it's 15 minus 0 over 8 minus 0. So the slope of this line is 15 over 8. Now, what do you think? You remember? Maybe you didn't do it last year. Karen, do you remember how to find the slope of the perpendicular? Because these are perpendicular. You have to flip that. And if you look at the sign, this is obviously a positive slope, and this is obviously a negative slope. To solve for y means I have to deal with 15ths. I don't want to deal with 15ths. Just leave it. Now, what about number 8? I probably copied it wrong. I copied it wrong. It should be 8/15. I just copied it wrong. I copied it as 18. Well, this is, you have tomorrow too. Manuel? Number 8. Now, do you want me to go, we did this problem in class. You want me to do it again?
What?
We did this problem in class except for angle P. Do you want me to do it again? What's true about these two angles? They're the same. So I called that x, and I called this x. Now, I got to find this arc. So what I do is I add up all the arcs, 168, 78, 146, and subtract that from 360. Now, I prefer to add rather than subtract, so I have to, because I always forget to borrow. so that this arc is 114. How big is this angle here? I'm going to draw my triangle out. How big is this angle here? It's the central angle. It's what? 114. This is x. This is isosceles. So what's true about 2x plus 114? It equals what? 180. So 2x equals 66. So x equals 33. Okay, Cole? So this, I have to erase something here. This is 33. That's 114. This is 66. This, what's 33 from 180? 127? Oh, no. I can subtract. Yeah, I don't like subtracting. 180 minus 33. 7. 147. That's 147. This is 90. And you add, and that's not a diameter, so I mean, oh, that's my mistake. That's not a diameter. That's 114. That's not 66. 78. So add them all up. P plus 147 plus 78 plus 90 adds up to how many degrees? The quadrilateral. 360. You can find out what P is. I think it's 45. What's wrong with number 9? What has to be true about these two angles? Well, all the angles together, I have two 90s plus 148 plus 36 equals 360. If I subtract the 180 out from both sides, 148 plus 36 has to equal 180, and it doesn't. Okay, what about the next ones? The true-false questions were hard. What about this one? Diagonals of a quadrilateral are congruent. Okay, so I'm going to draw two diagonals that are congruent. One's going to bisect the other. What kind of shape is that? What's that called? It's a kite. It's true. B, I thought was hard. I said it was true until I thought of another quadrilateral. First off, what do you mean by reflectional symmetry? If I draw this line here, if I reflect this side over to that side, they match up like a mirror. So if I fold the paper, these match up. If I fold the paper this way, these triangles don't match up. Can you think of a quadrilateral that does have a different one of directional symmetry? I didn't think of it right away, but what about a trapezoid? If I draw this line, it wasn't really a line, but that's okay, it works. I have another line of directional symmetry. What if I do this line? That doesn't work. So it has exactly one line. So this is false because the trapezoid also works. So both a kite and a trapezoid. Let's write that. Kite and a trapezoid. I think those problems are hard because you really have to think. Now, number C, letter C, if the diagonals are congruent and bisect each other, so these are congruent and they bisect each other, is that a square? Is that a square?
Yeah.
No, it's not. It's a rectangle. Yes. Could be a square. Does it have to be a square? Yeah, they do. The diagonals on a parallelogram bisect each other, but they're also congruent. Which one? Which one do you want to look at? Give me one. number one, this arc is 130. This is half of it. That's an inscribed angle. Yes?
Yeah,
Before I did, I slid it. Sorry. I'll slide it back. This. Yeah. You have to draw your radius, which is perpendicular. There was another one, though. Which was the other one? Okay. Now, I've done all these. Oh, I have a rhombus, and I want to find the angle. Now, what's true about this arc? That's a right angle. That's a right angle. We just did this. What's true about this arc and this angle here? They have to add up to what? 180. So this is 50. So how big is W? 50. Can't forget the things we learned in the beginning, because you will have a final exam that will include remembering about properties of rhombuses. Rhombi, I should say. Rhombi. Number 4.
So are we only doing the front page for?
Yes, so because tomorrow you have time to work in class too. If you want to do more, you can, but there. I drew the radius in, and the radius is perpendicular. So I get a right triangle.
This one identifies the semicircle again this one.
Hmm?
It wants to find
Which number? Current? Which one, 8? I always keep extra copies, by the way.
I think
Where's 8? That's a rectangle. Where's X? Well, these are parallel. So this is 32. Can't do 180.
it's 148.
I want to say these two are congruent. And they are, because they're parallel.
Okay.
Or are they? If I can do that, it's easy.
Why do we have to work kind of long?
Because we're done with the unit.
When are we taking the test? Friday?
Oh yeah, that has to be, that's a right angle. That's a semicircle. 180 minus 32. Yes. Test is Monday. I'm sorry, what? Tomorrow morning. If you want to do the retake for the last unit, come in tomorrow morning. All your homework needs to be done, and you come in to do test corrections. You're ready for the retake on Friday.